going to need a graphing calculator. So if you do not have one at this point, hit pause and find one and then come on back. Okay, your table of contents is 2 5 scatter plots and regression lines. Make sure you include the date. When is it good for two things to be positively correlated and negatively correlated? All right, so we've got some vocabulary review again, a prediction equation, a regression line, and a correlation coefficient. Hopefully remember back to Algebra 1 when you did those correlation projects. That's what we're talking about here again. Just a quick review over that. Again, hit pause if you need. All right, we are going to be writing down just some positive correlations, negative correlations. And so you need to do this part. Oh, this isn't going to work here. Let's see. That information, and that information you need to write down. So go ahead and hit pause. Then you'll want to do the reading math. Just read through that. Again, hit pause. All right, real world example number 1. So we're looking since the year 1985 at students who sent in applications to 2 colleges. So first it says make a scatter plot and then draw a line of fit. So you'll need to draw on an X and Y axis, a little grid that looks like what's given on the screen. And then we're going to plot these points. At 0, it's 20. 3, it's 18. 6, it's 15. So we need to draw a line of fit. So a line of fit is just any line that looks like it's going through the majority of the data. So a line like that is not going through the majority of the data. That is not a good fit line. Also, if I go like that, that is not a good fit line either. So we try to find it that it's going through the center of most of the points. There's a couple ways that it would look to be a fit line. There is a best line, and we'll be using your calculators to figure out what the best fit line is. But you just want to draw in a line that appears to be going through most of the data. Predict the percent of students who will send applications to 2 colleges in 2010. Well, we need to go back and look at our line. And first of all, where is 2010? How many years past will it be? So in 1985 is 0. So 1995 would be 10. 2000 would be 15. So 2010 would be 25. So we have to predict this out to 25 and figure out where we think this is going to be. Okay, since our graph has this squiggly line right here, it's hard for us to do that by predicting it off a graph. A better way might be to use our equation that we can make by using our calculator. So at this point, take out your calculators. And what we need to do is press Stat, Edit. And if you have a list, this is how you clear it out. You'll press the up arrow. You'll press Clear, do not hit Delete. And then you'll press the down arrow. You'll put years since 1985 into L1. So 0, enter. 3, enter, and so on. And then go to L2 and do the same there. calculator to figure out what is the best line to go through this information, you'll press your Stat key over to calculate, and then linear regression, number 4. Alright, your new calculators will look like this. And all you need to do is go down to calculate. Some of your calculators, it will say lin, reg, and then you'll type in L1, comma, L2, close your parentheses, and then hit enter. Again, L1 is found by pressing second 1, comma is right above the 7, L2 is second 2. Alright, I am ready to hit calculate, and I will press enter. So this is a good equation. Y equals negative 0.45, rounding, x minus 19.2. So let's write that down. Alright, and now we are ready to predict for 2010. If we go back to the previous screen again, we know that 2010 was at years since 1985 was 25. So 25 is the number we need to put in. So we'll say negative 0.45 times 25x plus 19.2. Alright, then go ahead and grab your calculators and type that in. Hit pause if you need. The answer is 7.95. That's what we predict in the year 2010. How accurate is this prediction? Well, the accuracy all depends upon the data that we got the information from. So if you go back and look at this graph that we made, we're looking at, are most of the data points close to the line, or are they all scattered out? If they are all close to the line, we can be pretty confident in our estimate. But if they are scattered all over the place, then we cannot feel very confident about our estimate or our prediction. In this case, the dots are all pretty close to the line, so we can say that we are pretty confident that our prediction is accurate. How accurate is this prediction? Well, let's say fairly accurate. Because the points fit the line well. Okay, again, let's do another example. We've got the data, we've got to put it into our graph, and we're going to make a scatter plot. We have to find the equation, graph the line, and then use the equation to predict the attendance in 2015. Alright, so again, go back to your calculators. You'll press Stat, Enter for edit. You'll press up to clear out your list. And on L1, clear out your list. And at this point, I would like you to hit pause, and then we'll come back once we have all the data together. So now you should be hitting pause. And then hopefully your calculator looks like this. It's always a good idea to go back and double check your numbers so that you don't make a mistake just because you mistyped something. Alright, we're ready to do that equation again. You press Stat, over to calculate. Number 4 for linear regression. Enter. Okay, so that is all ready. Again, if you have the other calculators, you need to press L1, comma, L2. So we're going to need to write down these numbers. But since this is such a long equation, there is an easier way that we would not actually have to write down these numbers. So let's go through that process again. Stat, calculate. Number 4. If you look on your calculator, if you have a calculator like this, I'll show you the other way for the other calculator in just a bit. This stored regression equation, we're going to press the vars key over to y-vars, function, press enter, y1, press enter. So that tells us we're going to store this equation in y1. And then you can press enter. If you do not have this type of calculator, you would do the same thing to get y1, but yours is going to look like this. Lin, reg, L1, comma, L2, comma, y1. And I'll just review with you again how we found that y1. Vars over to y-vars. Number 1 is function. Number 1 again is y1. I'm going to quit because I don't want to get another y1 in there. And there's our equation again. Now it doesn't appear that anything changed, but if you go into your y equals, you'll notice that that equation is typed into y1. I have an equation in y2. I'm going to clear that. Alright, now we found our equation. We have not looked at a graph, so let's do that. So to set up a graph, we're going to go second, y equals. We need to turn our plot on. So press enter on. It is then check to make sure it's on a scatter plot. And it says L1 and L2. Then we need to change your window. So this is our lowest x value. So we should go a little below that. Maybe 1975. Oh, I'm sorry, 65. And then let's go a little above that. How about 2010? Well, actually, we need to look at 2015. So it'd be good to go a little beyond 2015. How about 2020? We don't need to change our x scale. Our y minimum is right here. So we want to go below that. Maybe 9,000. And our y max, we maybe want to go with 53,000. And let's take a look at a graph of this. And our calculator makes a nice graph with the line running through it. And so you should sketch that graph down on your paper. And then we need to make a prediction. One way we can do that is by pressing the trace key. And if you look up at the top, the trace is on PL colon L1 comma L2. That means it's on plot 1. You want to press your up key so that it's on the equation. Once you're on the equation, we can press the trace key again. Or never mind, we already pressed the trace key. We just want to type in the year 2015. And press enter. And the y value is right there. It is 69,214 approximately. So 69,214 is the amount of money that they can expect in 2015. And that is the end of lesson 2.5.